Hi everybody, so this is number 98. It says operations on rational functions. We're going to focus on adding and subtracting. So let's start with a review. This is what we did yesterday. So factor the top, factor the bottom. It is division, so don't forget to flip. So let's see, on top, I have a GCF of 4xy. And I'm left with 2 minus 3x. Times, so the bottom, this one, that's a difference of two perfect squares, so 3x plus 2, 3x minus 2, and then this bottom right one, that's a GCF of 12x, 2 plus 3x. So a good amount cancels here. So we have the 2 plus 3x, 3 plus 2x, those are commutative. Remember, those are subtraction and they're reversed. So when those cancel, we need a negative. So I'm going to throw a negative there. So this one's a little tricky. I'm actually going to just do this simplifying in 2 steps. So I'm going to multiply the top together. Negative 48x squared y over 10x to the 5th y to the 3rd. So now I have x squared goes into this, we have a 3 left over, y, and a 2 left over, and then I can divide by 2, right? So this is a 5 and a 24. So I'm left with, I know, it's crazy looking, but as long as, if you can do it better, good for you. Mine is always super messy until I get to the end. And that is my answer. All right, so now we're going to do adding. So remember, if you are adding 1 over 7 plus 1 over 2, you need a common denominator. You find a common denominator by multiplying, right? So some students try to do like, oh, plus 2 plus 4. You can't just magically add to a fraction, right? If I have 1 over 7, that is not the same as 3 over 9, right? 3 over 9 is not the same as 1 over 7th plus, like that's awkward. That's not the case. So we have to do everything through multiplication. So what would be your common denominator with this? It's 1 over 4, it's 14, right? We just multiply 7 times 2 is 14. So we're going to do the same thing here. We're going to multiply. I'm going to multiply this left one by the denominator, x plus 4. But whatever you do to the bottom, we do to the top, x plus 4 on top. So I get 8x plus 32. Do not multiply these out. Leave it as x plus 2, x plus 4. And then we're going to do the same thing. This one, we're multiplying by x plus 2, x plus 2. Leave the denominator in factored form. The order doesn't actually matter. That's how I wrote the left fraction. 10x plus 10. 5x plus 10. Just kidding. So we end up getting 13x plus 42 over x plus 2 times x plus 4. Now, the reason I don't have you multiply it out is every so often the top is factorable and you'll get to cancel. You cannot factor 13x plus 42. So wait, yes you can. 13 goes into 13. That's x plus 4, isn't it? No, that's 52. Just kidding. That's 52, not 42. I got excited there. Thought that was going to cancel. Nope, so you're done. You can't factor that, so that is your answer. All right. I want you to pause the video and see what you can do with this one. So on the right, it should pop in your brain, oh, that's factorable. Is this factorable? Did I mess this up? No, it's right. Okay. I remember one of them I thought I did wrong. If you factor this right one, you get this. So then what's the common denominator? This is your common denominator. So we don't have to change the right one. We're going to leave the right one like this, because all we have to do is put in an x plus 4 into this problem, or m plus 4 over here. So we get m plus 4, m minus 7, and then what do we get on top? 5m plus 20. Let's see, what do we get? 5m plus 23 over m plus 4, m minus 7. And again, we can't factor the top, so we're done. And then again, if you, some of the I'm not a big, like, these are expressions, so I don't make a big deal out of this. If we were graphing, I would. But the domain of this, like, sometimes you'll see in answer keys online, m cannot equal -4 or 7. So if you ever are doing something and you see that, that's why. Because you can't have 0 in the denominator. All right, pause the video. Try this one on your own. All right, so let's see. What do we get here? I get w minus 5, w minus 3. So the left one we're good with. We just have to multiply the right one times w minus 3. All right, so my bottom, w minus 5, w minus 3, w squared minus 19, which is a really awkward looking difference of two perfect squares. Now with these, we are going to multiply the top out because we're going to be able to combine like terms. So I'm going to FOIL this top, right? So we get w squared minus 5w plus 5 plus 6, just kidding. 2 times 3 is 6, not 5. All right, so now be careful with the negative ones. What I typically do is I'll go through and I'll just change the signs so that when I combine like terms, it's more accurate. So my w squareds cancel, and I get 5w minus 25 over w minus 5, w minus 3, and then the top actually does factor. And then the w minus 5's cancel. So we end up with 5 over w minus 3. I love this problem. It's not overly hard, but it's just like the numbers aren't too crazy. The factoring is not that hard, but it's just like a process. I don't know. I love this problem. All right, last one. This is the hard one, the obnoxious one. Pause the video, see if you can figure it out. All right, 4 over 3x squared minus, I'm factoring the second half. So the GCF is x times 10x minus 7. Now this one is the hard one because it's obnoxious. The GCF, basically we're not going to quite multiply them because we don't want to have extra x's. So I'm going to multiply the right one times 3x so that I have the 3x squared. And the right one, I'm going to multiply by 10x minus 7. Remember, whatever we do on the bottom, we have to do on the top. So 3x on the top here, 10x minus 7 on the top here. So that gives me 40x minus 28 over 3x squared times 10x minus 7 minus 3x squared minus 15x. All right, so then I'm going to go through, I'm going to make that a plus, and then that becomes minus, that becomes plus. So that gives me negative 3x squared plus 55x minus 28 all over 3x squared times 10x minus 7. And then I have these really annoying numbers, and I'm like, can I factor it? And I literally sat here when I was doing this problem, is this factorable? And it's not. We're not. So you could do 28 times 3, 24, that's 84. And then what's everything that multiplies to 84? 1 times 84, 2 times 42, 3 times 28, 4 times 21, 5, 6 times 14, 7 times 12, 8, 9, 10. So none of those will give you 55. So through subtraction. So it's not factorable, and this is the answer. But you really you should check that whether it's factorable or not. In this case, it's not. But it's just a lot of work for a dumb, crazy answer. Very little was done. I don't know. It's not hard. It's just an annoying problem because it has such a gross answer. It's no fun when nothing cancels. All right, here is your homework again in the book. Guys, we have 1 lesson left. We can do it. The year is almost over. All right, have a great day. I will talk to you guys tomorrow. Bye. Turn my pen on.